I was talking to John recently, you know him as IPv0, and he was telling me, Knox, you need to learn Nornir. You need to see where it fits into the picture of things, where it fits into the big picture, and how it actually works, and the power that it can bring to the table. And here's the thing, I did. A couple weeks ago, I started getting into Nornir and learning all the bits and pieces, and now I've drank the Kool-Aid. I'm all aboard with the power of Nornir and how it greatly simplifies scripting when it comes to interacting with more devices. Now, throughout this video, we're going to talk more about where Nornir fits in. What does it really do, and how does it really work? And I'm going to give you some resources where you can get started learning Nornir too. But one of the things that's cool about Nornir is that it's very agnostic. It doesn't care which platform you're working with or which transport you're working with, as long as you have the ability to create your own transports or your own inventory or all of these other things. You can just plug it into Nornir and let Nornir do the rest of the work for you. So one of the things that I did recently was I took the Juniper PyEZ SDK, the Python library for working with Juniper devices, and I fit it to work within Nornir. So what we're going to cover in this video is how you can get started working with the Juniper Nornir PyEZ library that I created. Let's go. So if I'm describing Nornir to someone, basically what I would tell them is when it comes to learning Nornir, it's a little tough at first because there are three major moving parts to understand how it all fits together. But once you've gotten through that initial learning curve, then you're off to the races and it's smooth sailing. What we should talk about first is what Nornir really does at the end of the day. Let's go. A couple weeks ago, I launched my blog, and as recently as last night, I took to start talking about Nornir. If you scroll down just a hair, there's a blog post right here called Understanding Nornir for Network Automation. Now here's the gist of Nornir. Nornir is really broken down into three components, not unlike the MVC design pattern. And I kind of make the argument they call Nornir a network automation framework, and I guess that's technically correct. To me, it feels more like a network automation design pattern, which I think is really cool. Nornir does some things that you may be familiar with already. The first one is it separates inventory management from everything else that you do. This is exactly like Ansible. Think about how Ansible handles all of your inventory and the host variables and the group variables. There's even default settings and environment variables. And that's exactly how Nornir handles inventory too. The code, the playbooks that you write for Ansible are separate from the inventory. There is a part where you say, run it against these devices, but that's kind of the point. So the first thing that you should know about is inventory. And I kind of write all of these right here on the blog. You may want to read this too, because it's going to go into a little bit more detail and set up comparisons that you really care about. The second thing is you choose the transport mechanism yourself that plugs into Nornir. So you can use something like NetMiko as your transport library. You can use something like Scraply or Scraply netconf. You can use things like Napalm, or in my case, what I did is I choose to use the PyEZ, which is the Juniper SDK, as a transport. Really what PyEZ is over the hood is it just simplifies how we use NC client to interact with Juniper network devices, but it's very, very powerful and very mature. So the last piece that we should talk about is the actual code itself. You write one function one time. Then the way it all works, the way it all comes together is Nornir will take your one function, it'll apply it to all of the devices in your inventory, or a subset of them if you want, and it uses the transport mechanism that you specify. So if I scroll down here, here's an example of how Nornir works within PyEZ. All we have to do is we initialize Nornir with a config file. The config file points to all of the inventory pieces that we have within our library or within our directory. Notice nowhere in here are we seeing anything about hosts, or are we seeing IP addresses or usernames or passwords. That's because this config file is initializing Nornir, and it says all of the inventory is located over there. Worth pointing out, you don't have to use like YAML files. You could also hook it in to other things like Netbox to get all the inventory and secret secrets if you wanted to. Then beyond that, we say we want to run this specific function. In my case, it's PyEZ interface terse. This is the exact same thing as show interfaces terse within a Juniper environment, or it'd be like show IP interface brief within a Cisco environment, and then it spits out the results. So what really took place under the hood is this command right here, the run method. The run method says, perform this block of code or this code that you've written against every device that's in your inventory. And in this case, it's using the PyEZ library in order to do that. That's how Nornir works. So the cool thing about it is it does all of this stuff concurrently. It executes this code. We only wrote the code one time, and it executes the code across all the devices concurrently. It gathers all the results and then spits the results for each device out, or you can interact with those results programmatically. It's very, very cool. Again, I highly encourage you to read through this blog, or more importantly, if you're ready to get started really working with Nornir and understanding all of the different components and pieces that makes it work, John McGovern, aka IPv0, has content on CBT Nuggets dedicated to advanced network automation using Nornir. It will take you from zero to hero within CBT Nuggets using the Nornir framework. So I highly encourage you to check that out. So once you understand the point of Nornir and where it fits in, then we can talk about how to actually use it within the network automation context of a Juniper device. I have an SRX 300 here, a physical SRX 300 firewall within my environment. Here it is. Let me just bring it up right here. And you can see, there it is. I'm on the command line of this Juniper firewall. The cool thing about the PyEZ library is that we can now interact with this device programmatically. In fact, that's kind of the entire point of Juniper and Junos, the operating system. I mean, look, if you're new to Juniper, look at this configuration. Tell me, what does that look like to you, huh? Looks like structured data. It actually looks like JSON. And that's because under the hood, Juniper devices are all performing programmatic interactions to each other. Every command that we type, like show OSPF interfaces, if I pipe this to display XML RPC, the command show OSPF interface is actually issuing an XML API request. The RPC under the hood that it's issuing is this RPC right here, get OSPF interface information. Feels a lot like netconf, right? That's because this is what eventually became netconf. Juniper operating systems have been operating like this for a long time. The other cool thing is, if I just take off the RPC, I can see the response in XML in the programmatic output. Now, I don't have OSPF running on this device just yet, but here's the thing. This is what's really going on under the hood. Is it's just sending XML RPCs and receiving XML data back. We can do the same thing with JSON. We can do it with raw text. That's kind of the entire point. And now we can use PyEZ along with Nornir and hit all of these devices and issue all of these commands programmatically, all simultaneously, and then take programmatic actions against them. So here's how I'm going to get started working with the Nornir PyEZ library and interacting with this SRX 300 firewall. I've got my git bash pulled up here. If I give it a docker ps, we'll see I'm running netbox right now, but I'm not running anything else. So let's just start a blank Python container where we're going to do some development with Nornir PyEZ. I'll say docker run detached interactive. Let's give it a name like PyEZ tester. We're going to run the Python container and start off in bash. The container starts up, and now I can use VS Code to attach to it. So down here in the bottom left corner, I'll say attach. We'll choose attach to a running container, and there's my PyEZ tester. So the container starts up, and the first thing I'm going to do is fire up a new terminal, and we're going to get some of the requirements installed here. First thing I'm going to give it is a pip install Nornir I got to spell it right, Nornir _ PyEZ. Press enter. And there we go. We see it's installing 0.0.5, that's the release, as well as all the requirements in order to actually get PyEZ up and running. That includes Nornir, XML2dict, the Nornir utilities, and of course PyEZ. Let's also install rich, just because we like pretty output, right? Let's go ahead and get that going. Now what I'm going to do is I'm going to make a directory real quick. We'll call this makedir. Let's call this PyEZ tester and cd into PyEZ tester. And now I can add this folder right here, PyEZ tester. And this is where I can start using this as my staging grounds. First things first, I'm going to create a new file. That's going to be my config .yaml file. I'm going to create a new folder called hosts, a new folder called groups, and a new folder called defaults. Within defaults, I'm going to create a new file called defaults.yaml. Within groups, I'm going to create a new file called groups.yaml. And within hosts, I'm going to create a new file called hosts.yaml. Last thing is in my root directory, I'm going to create a new file, and we'll just call this runner.py or something like that, main.py, whatever, it doesn't matter. We're just going to call, this is going to be my main script where I perform my network automation tasks. Now it detects that this is a Python library, so let's go ahead and install all the things that it needs. And at this point, everything should be ready for me. Now what we have to do is we have to start putting the config in place, the hosts in place, the groups in place, and the defaults in place. I'm just going to paste these in. Again, I can't encourage you enough to go watch the content on CBT Nuggets to learn how these YAML files work together to build the inventory pieces, but you don't need to be bored to death watching me type in IP addresses and usernames or not. I'm just going to paste these in now, and then we're going to jump back to the runner.python script where we can see the PyEZ library actually in action. Okay, so fast forwarding a little bit, we've got my config that's in place that points to my different YAML files. I've got my hosts, which identify the IP address, groups, which identify a basic username and password for a lab environment, as well as things like the DNS server and NTP server as arbitrary data. And then I've got a default section that just kind of overrides all of it. Again, I can't stress this enough, go to CBT Nuggets to understand the inheritance model and how all of these different these different inventory devices and these different YAML files actually apply to your real script. Now it's time to actually put together a script where we can use the PyEZ library in order to perform some operations. The basic operation that we can do is the moment PyEZ connects into one of our devices, it actually retrieves facts about the device. So we created one of the methods that we could use is just PyEZ facts so that we could get the facts on our device. I'm going to paste in my import statements right here, and we'll save it real quick, and you'll see exactly how this is going to work. We're importing PyEZ facts from the library that we just installed. We're going to initialize Nornir, which is going to find all the inventory files based on what we specified in config. One of the Nornir utilities that we're going to have is it's going to print the result of all of the operations that it did against all of the different devices. And then lastly, we have the ability to do some pretty printing if we want to do that using rich. So if I paste in this block of code, here's how it's going to look. I'm just dynamically finding what is the path that this file was being run in. That way I can point it to exactly where the config file is. When it initializes Nornir, it's going to find that config file, and then when it finds that config file, it'll know exactly where all of the inventory specific items are. I'm just telling it run the specific task called PyEZ facts. That's where it goes and collects the facts and retrieves all of the results back. Now in this case, I'm printing out the result of that task. That's an important thing within Nornir that you'll learn a lot about, is that it's going to just print the result of that task for the device that we ran it against. So here we go. I'm just going to run this script real quick. We'll say it's a Python file and watch it take place. Also worth pointing out while it's running this, see the print right here? This is going to be a pretty print because we actually imported it from rich. So it's not the traditional print, it's going to be a nice print. And there it is, right there. There's the output. Let's bring it on up. And we see the full output of the facts from running the PyEZ facts thing. Now the thing to keep in mind is in my inventory, I only have one SRX device. What would have really happened is if I had a huge inventory, it would have run this facts command against all the devices. Again, I can't stress this enough. Look at this code. There's no for loop. There's no specifying that there's an inventory and we need to loop over each one of the inventory and run this command. We just say use the PyEZ facts and execute this command across the entire topology. That's the entire point. Nornir is what's handling connecting into each one of those devices simultaneously using the PyEZ library. The big benefit here is you write your code one time. You write one function, and then Nornir handles the rest. Now, as a different thing that I'm just going to show off real quick, let's do print results so you can see what the Nornir result looks like, and we'll say response. If I run this Python file one more time real quick, you'll see how the output changes a little bit when we use Nornir's built-in print result. There we go. So in this case, we actually get some output that says we're running the facts, and then we get this green output that says the facts command was successfully run, and then it shows you for each one of the results or each one of the objects in your inventory what the results of that run were. So now let's step up our skills a notch and do something a little more complicated, like changing the configuration. Recall earlier that I didn't have OSPF running. Here's how I would go about actually changing the OSPF configuration using the PyEZ config module. Up here on import, I'm going to say PyEZ config, and what we'll do is we'll build a payload. And I'll hit enter a few times and payload. Now this payload could come in a bunch of different forms. It could come in the form of JSON. It could come in the form of raw text, just like this output looks like right here. Because it's not quite JSON, right? We don't see quotes and we don't see colons, but we can actually use this exact structure or convention to bring a payload in using PyEZ config. So we've got JSON, we've got that ASCII text version of JSON, we've got XML, or we could even use set commands to push in data. Beyond that, with the PyEZ config method, we could even use JNCIA templating. So we could specify the path to a template and then the path to the data, or we could retrieve the data from our host file or group file, and it will combine those all together. This is all part of the power of PyEZ and the PyEZ config method. You have a bunch of different ways of changing the config. So if I use XML, here's what I'm going to do. I'm going to start typing the XML here, and what I'm going to do is I'm going to come back to it when it's done, because this config is going to be, kind of long. I'm just going to use an XML subtree. So it's going to start with the configuration, then it's going to go protocols, then OSPF, then area, then the interface, then the name, and that's how it'll run OSPF. So this is where it's going to start to get fun. You see now on the screen, we actually have the payload that we're going to be sending in. The protocols, OSPF, area, name, interface. We say which interface we want it to run on. And I'm also giving it a priority of 200. Hopefully this one becomes the designated router with a priority that high. So in the past, when we were running this, here's what we did. We told Nornir to run one specific command. But one of the cool things that we did with this particular Nornir payload, and especially when we're working with Juniper Devices, is we have a difference between the candidate data store and the actual running or committed data store. So what we have to do here is we're going to be issuing this payload into the candidate data store, and I can tell it to either commit that data store right now, that way this payload becomes active right away. I can also use the PyEZ diff function, so that way we can see a diff of what's changed within our configuration, and then once we've validated that that diff looks good, we can tell it to commit. So rather than just running the PyEZ config just raw right out of Nornir, what we're going to do is we're actually going to build a function that runs a series of tasks, like issuing the payload in, checking the diff to make sure it looks good, and then committing the candidate data store to the running data store. So here's what we're going to do. I'm going to say def to define a function. We'll call this OSPF config, and it has to take a parameter of a task. Remember that the task is really what's being run against each one of these devices. So when we define a function, we're saying for each one of these devices, we're going to be sending you a task to run. So all of our functions take a task, that way it runs this block of code against each one of our devices whenever Nornir starts to run it. We're going to be sending in the config, so let's grab the response back here and save it in a variable called send response. We'll say for our task, run the PyEZ config operation. I'll explicitly say this is going to be the task name that we want to be running. Next, I'll explicitly say my payload is going to be the variable that we specified above, payload. The PyEZ config method itself, the function itself, takes a set of different variables. These could be the payload, this could be the template path, this could be the template variables, as well as what is the data serialization that we're actually sending in. In my case, we're sending in an XML payload rather than a set command payload or a JSON payload, so we have to specify that too. The default operation is that it just defaults to the raw text, which was this format here. This would be the text payload. It's not JSON, it's not XML, it's just kind of the Juniper specific text output. So here the parameter that we'll specify now is going to be the data underscore format, and it's going to be XML, and we'll close my parentheses. Now this sends this config into the candidate data store. It doesn't check for the diff, and it doesn't actually perform the commit operation. So for that, we're going to import a couple more libraries, but it's worth pointing out, we could use commit now and set it to true, and it would automatically perform the commit operation and quit out of the actual SSH or netconf session. So I'll hit save just to format this out, and we're going to import PyEZ diff as well as PyEZ commit. So we'll say if we do get a response back, we'll run another command. We're going to run another task, and we're going to save this as diff response. We'll say task.run, and this time we don't have to specify anything special here. So we can just say run PyEZ diff. What PyEZ diff does is it checks the candidate data store versus the committed data store and returns the differential about what's changed. Then, once we have a diff response, if there is a diff response, showing that we were able to successfully apply our configuration to the candidate data store, we'll actually run the commit operation, saving that in commit response. So let's say task.run, and we'll use the PyEZ commit operation. Now, it's worth pointing out this performs commit check to validate that this will pass the configuration change before it actually performs the commit operation. If commit check fails, it will actually perform a rollback by default, so we're not altering the data store in a bad way. That way somebody logs in later and goes, what the heck's going on here? We want to make sure that we clean up our mess if anything goes particularly wrong. So now all I have to do now is in the Nornir run command, we're going to tell it run the OSPF config function. So Nornir is going to pass in the task itself for each one of the devices in our inventory, and then it runs all of these commands against each one of those devices. In my case, it's just an SRX device. We're going to use the Nornir print result right now. That way it prints each one of these tasks out individually, and we can see the results of each one of these tasks. So here goes nothing. Let's apply OSPF to this SRX device. We'll start debugging. There's the Python file. Let me bring the terminal output up. Also worth pointing out, this does take a while. My SRX device is really old. It's got a crappy little data store, like a little USB thumb drive that I think it's running on. So the commit operation itself sometimes takes several minutes. I've increased the commit timeout to be 300 seconds as opposed to the default 30 seconds. Sometimes you actually do run into an issue where the commit response comes back a little slow because you have a huge running config or something like that. So the PyEZ config default timeout for the commit operation is actually 300 seconds as opposed to the 30 seconds. And there it is, look at that. As I was talking, we got a successful deploy message. First of all, here's the configuration that it was sent in. We see under PyEZ config, this was the config operation that was sent in using XML. Here's the PyEZ diff. Look at that. It shows we're adding all of these lines to the running config, and there's all the pluses. And then lastly, when it goes to commit, we've got a successful commit. The moment of truth. Let's just get out of this. Let's actually, watch us do show edit. Let's go into edit protocols and show. And there it is, right there. We've now added OSPF into the mix. If I go to top, exit, and if I do show OSPF interfaces, there we go, right there. So using the PyEZ library in conjunction with Nornir, I can now run this operation against every device in my inventory by only coding it one time. That's the power. So what I want to encourage you to do is, if you really want to get into this and see all of the different functions and operations that are available within PyEZ and Nornir, first of all, check out GitHub as well as the Read the Docs links. Make sure you have some fun exploring those Read the Docs links, especially if you want to start using JNCIA templating. We cover how to do that in the docs as well. So that's been getting started with the Nornir PyEZ plugin connector. Thanks for stopping by, y'all. I'll see you in the next one.